Humans have been accustomed to walking on Earth's ground since the beginning of our existence. Our bodies have developed to standing on the solid ground beneath our feet. However, when we fly, our bodies can become confused with its position, resulting in spatial disorientation. Spatial disorientation is defined by the human body's ability to maintain its position directed towards the surrounding environment relative to the Earth. Basically, all that fancy wording means is that we are aware of our surroundings and our position compared to them unless spatial disorientation occurs, which would obviously be very dangerous during flight. Using a fluid in our inner ear called endolymph, and also tiny hairs called cubula, our bodies can work with inertia to determine our angular position. This works most of the time during flight. However, when the plane is in a turn for longer than 20 seconds, the fluid catches up to the hairs due to friction from the canal wall becoming stronger than inertia. When the fluid reaches the hairs, it causes them to stand up, sending a signal to the brain that the plane has stopped. However, it is still in the midst of a turn. This is a diagram showing the effects of spatial disorientation before turning, at the start of the turn, during constant turn, and finally after the turn. So, looking at the diagram, you can see that after the turn, the pilot gets the feeling that he's turning in the opposite direction. Obviously, this is extremely dangerous because he may try to correct this turn that does not actually exist. This causes limitations on what humans can do in commercial flight and space exhibitions as well. We must be careful to avoid this dangerous effect. To prevent spatial disorientation, the use of other instruments help guide us when our own senses fail. They can tell us our position relative to the ground, our altitude, and other necessities when our senses are compromised due to this syndrome. Another way to overcome spatial disorientation is to fly with a co-pilot for a second set of eyes to help look over what the plane is doing. Illusions that are caused from spatial disorientation include the graveyard spin that occurs to a pilot who has entered a spin. For example, a pilot who enters a spin to the left will feel the sensation of spinning in that direction. If he continues the spin, the feeling will decrease. If the pilot applies right rudder to stop the left spin, he will feel a spin in the opposite direction, which is to the right. His response to the plane feeling as if it were spinning to the right is to apply left rudder to stop it. However, by applying this rudder, he will re-enter the left spin but not realize it. This will cause the plane to lose altitude very quickly and ultimately lead to a crash. Another illusion is the graveyard spiral, which is more common than the graveyard spin. This illusion occurs when a pilot returns to level flight after a bank turn for over 20 seconds. For example, a pilot who enters a banking turn to the left will feel the turning in that direction. If the turn continues for over 20 seconds, the pilot will lose the feeling of the turn. Now, when the pilot attempts to level the wings, he will feel as if the plane were turning in the opposite direction, which is to the right. If he believes this, he will try to correct it by turning left and ultimately re-enter the original left banking turn. During this left turn, the plane will lose altitude quickly. If the pilot does not recognize this illusion and level the wings, the airplane will keep turning left and lose altitude until it hits the ground. The Coriolis illusion occurs when the pilot tilts his head up or down, left or right, or even sideways. It produces a sensation to the pilot that the aircraft is rolling, pitching, and yawing all at the same time. This feels much like rolling down a hill. It can make the pilot quickly become confused and lose control of the plane. The head-up illusion involves a sudden increase in acceleration during level flight where the pilot thinks the nose of the aircraft is pointing upward. His response to this is to push on the yoke and pitch the nose of the aircraft downward, straight towards the ground without him realizing. The head-down illusion is the same thing except it involves a sudden decrease in acceleration during level flight. In this case, the pilot perceives the plane's nose as pointing downward, and to counteract this, he pitches the plane upward, causing it to stall. In conclusion, spatial disorientation is extremely dangerous and can have various effects on both new and experienced pilots. It is important to trust the instruments in the plane and to not fall for the many illusions that it can cause. Spatial disorientation accounts for about 10% of plane crashes. 90% of those are fatal. An increase in training and general awareness for spatial disorientation will allow for fewer numbers of crashes and will save more lives.